Good morning, everyone. Today, I'm the one who's feeling very sleepy. Okay, so yesterday we derived these four relations. Okay, I hope you tried to remember these four, right? Two about velocity for x and y, and two about displacement for x and y, right? And again, all of this was based on the basic table, right? This table, that the x component of initial velocity is v0 cos theta 0 and the y component of initial velocity is v0 sin theta 0, and acceleration in x direction or x component of acceleration is 0 and y component of acceleration is g downwards, right? That is because Earth only attracts objects downwards, that is towards the negative y-axis, no, neither left nor right, okay, not sideways, not horizontal, okay. No, I'm not sitting in the middle of the road, of course. Okay. Right now, uh, so after having derived these four basic equations, which are very useful, right? Let's go to the next ones. That is, we will derive relations or formulas of range and time of flight and time for maximum height and all that. Okay, so let's start with that. Okay, so first of all, let's talk about time of flight. Okay, let's talk about time of flight. Again, time of flight means the time for which it remains in air, right? The time for which whatever you are throwing remains in air. Okay, so as usual, we should draw diagrams. They help us imagine what we are doing, right? So this is, let's say, y-axis and this is x-axis. This is ground, all right? So what we are doing is, let's say we are throwing something from origin and it falls here like this. Okay, so let's say this is the point O and let's say this is the point A, right? So if you want to find time of flight, then time of flight is the time interval required by object to go from O to A. I'm sure that is absolutely clear, right? Time of flight is the time required by the object to go from O to A, right? So now, so there is something very particular about O to A. If you realize it, do you understand that for O to A, okay, so again, whenever you are doing any kind of calculation, I suggest that you write for which point to which point. Do you agree with this? for O to A, delta y is 0. The y component of displacement is 0 for O to A, because you can see that at whatever y coordinate this is, like this is 0 0, then this is going to be r comma 0. I hope that makes sense, right? R comma 0 range, this is range, but right now we are not talking about range, okay, just mentioning that, right? So this is r comma 0. So that would essentially mean, that delta y is 0. Now if delta y is 0, yesterday we just derived a basic relation of delta y for projectile motion, and that is equal to v0 sine theta 0 t minus half g square, right? Okay, I think that is absolutely clear, right? This is what we derived yesterday. So by solving this equation, we will be able to get time. So that's what I'm going to ask you to do. Solve this, find what is t equal to. Come on, solve this equation to find out what is t equal to. Do it, come on, do the maths yourself. આઈડિયા મેં આપી દીધો, એક્ઝિક્યુશન તમારે કરવાનું, તો તમને આવડવા મળશે. ધીરે ધીરે તમને આઈડિયા આવડી જશે બધા. ઓકે, વેરી ગુડ દિવ્યા. T equal to 0, Priyansh, I agree that mathematically you get two answers. One is t equal to 0. But do you think it will take 0 time to go from O to A? Ria, check your calculations, please. No, Jay. T na answer ma T no આવી શકે. First of all, okay, you cannot have T in T's answer. That is not valid. Yes, Dhruvi, that is right. કેમ આટલી વાર એક ઇક્વેશન સોલ્વ કરવામાં, હે? Yes, Harsh, that is right. Ankita, it is right. T equal to 5. Wow. Okay, let me solve it. So first of all, we have got this as 0, so we can actually take T common. Do you see, all of you? T is common. So this is the first step, right? This is the first step. So now whenever you are given two things like this, x into y is 0. So there are two possibilities, x is 0 or y is 0. That's how normally things happen, right? Okay, there are exceptions, પણ અહીંયા મારે તમને maths નથી શીખવાડવાનું. So you get t is equal to 0 or v0 sine theta 0 minus 1 by 2 gt is equal to 0. Okay, so two possibilities. Let's work on this second one. Okay, let's work on the second one, right? T equal to 0 તો આવી ગયું, we'll keep that aside. So here what do we get? Here we will get v0 sine theta 0 is equal to 1 by 2 gt, putting this term on that side. So that's why t is equal to 2v0 sine theta 0 divided by g. So now we have got two possibilities, this or this. Now clearly this is not possible because we are trying to find the time to go from O to A. તો તમને એવું લાગે છે કે 0 સેકન્ડમાં કે 0 ટાઈમમાં અહીંથી અહીંયા આવી જાય મેજિકલી appearing and disappearing, right? So that's obviously not going to happen. Clear? So this is why this answer is not possible. એટલે એને ભૂલી જાઓ. This is your correct answer. But the time taken to go from O to A, that's actually called time of flight, right? That's actually called time of flight. So thus we have final answer, time of flight is equal to 2v0 sine theta 0 by g. You can also write it like this. I hope you have understood that as well, right? Because v0y is v0 sine theta 0. Okay, Ayushi, I answered what you said automatically. I didn't see your question actually. I saw it just now. All right, so this is what we get, right? So this is the formula of time of flight. That is, if you throw something from the ground, then it will stay, it will be flying in the air. So that is going like this will take this much time, right? After that much time it will hit the ground, right? After that much time, after this time, it will hit the ground. Okay, so that's what we have found, right? Now let's go to the next one, range. Okay, second one, range. R. Time to draw diagram again. અરે 5 વાર ડ્રો કરવો પડે, ભલે ડ્રો કરવો પડે, એનાથી તમારું ઇમેજિનેશન ઇમ્પ્રૂવ થશે and you will be able to solve all these questions very easily. Okay, so let's say once again you throw something from here, right, and it falls over here. So O A again, and this distance is range, correct? That's what we want to find. Okay, so again for O to A, range, sorry, for O to A, delta x is nothing but the range, correct? R. Clear? For O to A, delta x is R. So we can write R is equal to, now instead of delta x, we have derived something earlier, right? Do you remember what we have derived? What is delta x equal to earlier? I would ask you to remember. કદાચ નો આવડે તો કઈ નહીં, ડેલ્ટા એક્સ ની ફોર્મ્યુલા તો આવડે ને. શું આવે? v0x t plus half ax t square, right? For those who don't remember, like me, હું તો યાદ રાખવાની ટ્રાય નથી કરતો. It's not even required. આમાં મૂકી દો એટલે આવી જ જાય, right? v0 cos theta 0 t and ax is 0, તો પતી ગયું, એ લખવાની જરૂર નહીં, done. R is equal to this, but time to go from O to A, we have already found that, right? What is that time called? Time to go from O to A, what is that time called? Time to go from O to A, it is called time of flight. અભી હાલ derive કર્યું છે, તો એની value મૂકી દઈ. So here we should actually write T is equal to TF. In this particular situation, for O to A, the time interval is actually same as time of flight. So therefore R is equal to v0 cos theta 0 TF. Okay, but what is TF? We derived a formula for TF. Let's use that formula here. What's the formula of TF? 2v0 sine theta 0 by g, right? That's what we derived, okay, just before a while. Clear? Right? So this is v0 cos theta 0 into 2v0 sine theta 0 by g. You can simplify it, right? We can simplify it, okay, and we can write it as 2v0 square sine theta 0 cos theta 0 by g math students, so you see, first of all, this is a valid formula of range, everyone. Okay, this is a valid formula of range. Okay, but there are a few more things that we could do, right? Probably math students have studied this. I'm not so sure about this. Have you studied this, math students? Have you studied that 2 sine theta cos theta is sine 2 theta? Because typically Lakshman sir is very fast with math syllabus, right? And I am the one who is very slow, right? Okay. 10th માં હતું એમ હવે ઘરે જા સાહિલ. 10th માં હોય જ ન શકે. ઓકે, સો 10th માં મને એ ખબર છે, તમને એ નહોતું આવડતું કે sin 2 થીટા કેવી રીતે ફાઇન્ડ કરાય. આ ડિરાઈવ કરાવ્યું હતું, એમ ડિરાઈવ કરાવ્યું હતું. ડિરાઈવ. ઓકે, એટલે આદુ અધૂરું બધું ગમે તે જ્ઞાન ન આપવું મને. હા, તો તું ત્યાં જ રહેજે ભાઈ. Okay, so 2 sin theta cos theta is equal to sin 2 theta is a formula of trigonometry, right? So if you use that here, you get r is equal to v0 square sin 2 theta 0 by g. Okay, r is equal to v0 square sin 2 theta 0 by g. We have used this formula. Again, biology students, please do not worry about it. કેવી રીતે આવે એ બધું, આ ફોર્મ્યુલાનું રીઝન તમારે જાણવાની જરૂર નથી, right? If I want, I could explain it, but like I've said, it is 11th standard mathematics, right? There is absolutely no need for biology students to know about it, right? ગોખી નાખવાની, તમારે તો એટલું જ કરવું પડશે, right? Okay, so now this is the range formula. You can also write the range formula in one more way. Okay, one more way. So have a look at this. Here, when we did this, I hope all of you do realize that v0 cos theta 0 is v0 x. Okay, and v0 sin theta 0 is v0 y. So we get a new formula of range, and that is this. Clear, everyone? Range is also equal to 2v0x v0y by, sorry, 2v0x v0y by g. Okay, રાઈટ. હવે તમને એવું થશે આટલી બધી ફોર્મ્યુલા આમાંથી કઈ યાદ રાખવાની, બધી એક જ છે. હું તો કહું આ એક યાદ રાખો. ઓકે, મેથ સ્ટુડન્ટ્સને તો એમને જ આવડી જશે, અને આ બાયોલોજી વાળા ગોખી નાખો એટલે કામ પૂરું, right? You can actually verify it if you want. That is what you did in 10th. Okay, for those people who were wondering, અમે તો ભણી ગયા છીએ સર 10th માં આવું, you are highly intelligent, right? This is what you have studied. This is what you would have verified. You would have taken theta is 30 and then you have tried, okay, 2 into sine theta 1 by 2, okay, 2 into cos theta root 3 by 2, okay, cos 30, and now here sine 2 theta. So if theta is 30, 2 theta is 60. So what is sine 60? Sine 60 degrees is root 3 by 2. Okay, તો તમારા સરે તમને 10th માં આ કરાવ્યું હતું, માય ડિયર ફ્રેન્ડ્સ. ઓકે, તમારા સરે તમને 10th માં આટલું કરાવ્યું હતું કે આ બે સેમ આવે છે. કેવી રીતે? હિયર ઇફ યુ રાઇટ 2, this is right what you write, and this is what you write. Here you get sine 60, so that is root 3 by 2. Hooray! Left side is equal to right side. Okay, this is not called proof. અને આ ફોર્મ્યુલા ભણાય ન કહેવાય, આ તો કોઈ કે તમને આપી દીધી, right? Okay, I hope you understand what I am saying. ભણ્યા ત્યારે જ કહેવાય જ્યારે આપણને ખબર પડે કે એ કેવી રીતે આવ્યું. આટલું જ આવ્યું હતું ને 10th માં. બહુ તો થીટા ઇક્વલ ટુ 45 ને 90 માટે કરી દીધું હશે તમને, બરાબર ને? 2 into 1 by root 2 into 1 by root 2. Hooray! 1. Okay, and sine 90 also 1. See, I know all of this because I've taught 10th standard maths for 3 years. I've taught 9th, 10th standard science for 3 years. Okay, I've taught 11th and 12th standard maths for 7 years. Okay, and I have taught physics for 7 years to 11th and 12th. એટલે આ બધું મને ખબર છે કયું કયા લેવલે કોણ શું ભણાવતું હોય, એટલે that's why I'm not surprised. તમે ગમે તે કહો મને ખબર હોય. Okay, yeah, so which formula to remember for range? All of these. Okay, you have to remember all of these. I'd say if you can remember all, very good. બાકી મારા માટે બધી એક જ છે, હું તો ગમે તે એક યાદ રાખીને કન્વર્ટ કરતા શીખી લઉં. Okay, so it's your choice really, whichever you want to do. All are same, પછી તમને વેલ્યુ મુક્ત આવડી જોઈએ. All are useful, right? All are useful. Okay, so that's done for range. Let's go to the next one. Okay, time for maximum height, right? Time for maximum height. Now before we go to time for maximum height, I would like to show you an animation, right? Okay, because that's very useful. So we're going to algo do now. Okay, all right, everyone can see algo do. Okay, now so we are going to observe the trajectory or the path carefully. Thank you. We're going to observe its path carefully, right? Here is its velocity right now. Right now I've set this angle, initial angle, to be 45, I think. I'm not so sure. Let me just verify that. Velocity, no, okay, it's 39. Let's make it some nice angle like 30. Okay, let's make it 30. Okay, fine. So here, you know what you're seeing over here? Can you see these numbers? Velocity x, velocity y. Can you see that? Right, what you are seeing here, this is the x component of initial velocity right now. Okay, this is the x component of velocity and this is the y component of velocity. You could calculate that. See, if v0 is 10 and theta 0 is 30 degree, then v0x means v0 cos theta 0, right? So that is going to be 10 into cos 30 means root 3 by 2. So 5 into root 3, so 5 into 1.73, right? So I think you get a 5 here, carry 1, 8, 35, 36, 83, right? So I hope you understood that this is what it is showing. Clear? Okay. Right now, let's start the animation so that all of us can see. So my point is actually about the maximum height, all right? Okay, what happens when the particle or this object reaches its maximum height? Okay, so let's slow this down so all of us can see it carefully. Okay, it's still not at its maximum height, right? I hope all of you are seeing it's still not at its maximum height. You see, now it is at its maximum height, nearly. Okay, I tried my best to stop it over there, right? If I'll allow it to play it further, it will fall down like this. All right. Now, I just want to mention one thing. I'll draw it here and then we will go back as well, right? Okay, how to set it. So do you see that over here, where there is maximum height, if I will draw a tangent over, right? I'm sorry, I'm just not so used to this. If we will draw a tangent at its maximum height, you see this tangent is going to be horizontal, right? I thought we are writing, okay. We will get that the tangent is horizontal, right? Over here the tangent is horizontal, all right, at this maximum height, right? I hope you realize that if you draw a shape like this, at this highest point the tangent is horizontal. Is that okay? Right? Is this concept clear? At the highest point this tangent should be horizontal. Is that concept clear? Maths no concept છે પણ આપણા માટે કામનો છે, right? At this highest point. And I hope you remember the sentence that we have for physics. It's that velocity is in direction along tangent to the path. Remember, this is the path. And a path kehવાય ને, અને graph no kehવાય, right? We saw the object move like this, like this, like this, like this, right? So this is the path. So here, if we draw at the highest point, if we draw a tangent to the path, if we draw tangent to the path, then that tangent is horizontal. And because that tangent is horizontal, that means the velocity vector, because that tangent is horizontal, this velocity vector should also be horizontal. At which point? At highest point. So overall what I'm saying is that if you just go back over here to where the particle is at this highest point, we are seeing that the velocity vector is horizontal. That's the whole thing that I'm trying to explain, right? This velocity vector is horizontal. Is that clear, everyone? Right? Okay. No, I don't want to turn off gravity anywhere. Right? Okay, so let's go to the board once again, and let's go to the board once again. Okay. Yeah, before that, just one thing that I'd like to write over here so that you will understand this. It is that here, if I talk about at this point, okay, at this point, at the highest point, at the highest point, velocity vector is horizontal. Okay, not only that, we have vy is equal to 0. Is this clear? We have vy means y component of velocity, y component of velocity. Is this clear, all of you? This is very crucial to understand. જે આપણે આગળ કરવાના છે ને એના માટે આ એકદમ નેસેસરી જેવું છે. Is this absolutely clear? See, if you have got a horizontal vector, right, and if you try to make a rectangle around it, I hope you realize that a horizontal vector બહુ intuitive છે આમ તો. આ હોરિઝોન્ટલ વેક્ટર ને એક જ હોરિઝોન્ટલ કોમ્પોનેન્ટ જ છે ને, there is nothing in vertical. I hope you see that, right? There is nothing in vertical, it has only horizontal component, right? Does that make sense, all of you? Coordinates no kehવાય, components, Ria, right? Again, see, if you would consider, if you would consider vector like this, vertical vector, right? Suppose you consider a vertical vector, then that would be something like 3j caret, isn't it? And suppose you consider a horizontal vector, then it would be something like 5i caret, let's say, correct? So this is only having x component and it has no y component, right? Because it is horizontal. And similarly, this kind of vector which is vertical, it has only y component and it has no x component, correct? I hope that makes sense. So its y component here is 0, right? The y component of this velocity vector is 0. I hope now that made everything absolutely clear, right? બહુ ઓછા લોકો રિપ્લાય આપે છે. પ્લીઝ એવરીવન ઇન્ટરેક્ટ. યસ નો જ કહેવાનું છે, એસે નથી લખવાનો, બરાબર ને? સો આઈ વુડ લાઈક ઓલ ઓફ યુ ટુ ઇન્ટરેક્ટ. મને ખબર પડે તમને શું આવડ્યું, તો મને સમજાવવાની ખબર પડે ને આગળ, રાઈટ? See, you should understand that as a teacher I probably have 10 different ways to explain the same thing. પછી મારે કયા લેવલ પર જવું ને એ તમે શું કહો છો એની ઉપરથી મને ખબર પડે, right? Okay, so here, because this is a horizontal vector and a horizontal vector has y component 0, right? Any vector which is horizontal of course has nothing in y, right? So let's go back to that the screen, so you'll be able to see it. There I can draw everything with freedom. Okay, so once again what I was saying is that if you have got a horizontal vector like this, then it's got a y component as 0 because it is only in the y direction. Sorry, it is only in the x direction, not in the y direction. આમ ઉપર સહેજે નથી ને, ઉપર નથી, નીચે નથી, right? So it's only in the x direction. That's why vy is 0. Okay, so now let's take that point and do it for time for maximum height. Okay, time for maximum height. So once again, let me write those sentences. If you didn't write it over there, I want you to definitely make it clear. At the point of maximum height, at the point of maximum height, velocity of particle is horizontal. At the point of maximum height, velocity of particle is horizontal. Therefore, Vy is equal to 0, right? Reason, horizontal vector has only x component and no y component, right? I hope you realize that because clearly it's parallel to x axis. બરાબર, આવું કંઈક છે. હવે તો આવડી જ ગયું હોવું જોઈએ મને એવું લાગે છે, આટલી બધી વખત મેં ઈ ને એ વસ્તુ સમજાવી તમને. ચલો કઈ વાંધો નહીં. You could also do it by angle, જેને બહુ trigonometry ગમતું હોય, right? This makes 0 angle, એવું થાય ને? ચલો, Vy is 0, right? So now we want to find time. Okay, so do we have a relation that tells us Vy at some particular time t? Have we derived such a relation for projectile motion? bolo फटाफट. Have we derived such a relation? So let's use that relation here. So the relation is The relation is what? I want to know from you all. કે તમે આખું કરી નાખશો અને મને ફાઇનલ આન્સર કહી દેશો. હાલો કહી દો ફાઇનલ આન્સર. ટેલ મી વોટ્સ ધ ફાઇનલ આન્સર ઓફ TM. Draw diagram. I'll give you hint. You have to do calculation for O to this point, let's say B, till here. Right? You have to do calculations for O to B. Right? કરી નાખ્યું? થઈ ગયું? Yes, Dharmi, that is right. Delta Y won't help. I mean, delta Y won't help. Because we want to find time, we already don't know what is delta Y, right? Okay, let me do it. Let me do it. See, we want to know how much time it takes to go from A to B, from O to B. Time to go from O to B, that is time TM. All right, clear? So if we use the equation that we have derived earlier, I hope all of you remember this equation, right? Is that okay? Yes, I think many of you got the answer also. Very good. Well done, people. Well done. So based on this, we can easily find the answer, right? Based on this, we can easily find the answer. We can say Vy is 0 at which point? At the point B, right? Basically, this is first equation of kinematics. I hope you see that. I hope everyone realizes that this is nothing but the first equation of kinematics, right? So if you would write Vy is V0 sine theta 0 minus GT and put it equal to 0, so you'll get T is equal to, very simple calculation, V0 sine theta 0 by G, but this T is nothing but Tm, right? So final answer is that Tm is equal to V0 sine theta 0 by G, or it is equal to V0y by G, right? So here is another important formula. Right, here is another important formula, right? Okay, everyone. Now, very quickly, let's move on to one more thing. Do you see any simple relation? Do you see any simple relation between these two? Check your notes. Do you see any simple relation between these two? If yes, what is that relation? If yes, what is that relation? Yes, very good, people, very good. Correct, correct. Check it. I think you have made some mistake. Check it. Others have got it right. Yes, Chintan. Yeah, that's right. Very good. So we are getting a relation. We are getting a relation that time of flight. We're getting a relation that time of flight is 2 times time of maximum height. Yes or no? Or you could also write it like this. બધું એક જ છે. એમાં કઈ confusion ન થવું જોઈએ. Right? Or this, whichever you want. Both are okay. Right? Both are okay. Right? I hope everyone noticed this relation, isn't it? So I think many people would have found it quite intuitive. તમને એવું લાગ્યું હશે કે હા સર અમને તો આવું હતું જ કે આમ જ આવશે. Because if you realize B is halfway through, and the x component of velocity is constant. I hope you all remember that B is halfway through and the x component of velocity is constant. That's why this happened, right? That's why this happened. Okay, right? Okay, so this is it. Again, you could remember either this or this, whichever you like, no problem. Both are same, right? चलो एक आ रिलेशन થઈ ગયું. Next, maximum height. Maximum height, h, capital H. Okay, do not write small h, it can cause confusion. So let's say once again that you're throwing something from this ground, goes off like this, reaches this point A. Okay, but that's not what we are here for. We are here for B, right? Maximum height. So here again, its velocity will be horizontal. All right. So we have Vy equal to 0 at this point B. Clear? This is what I've already explained. Right. So now this is H. I'm sure everyone understands that. And that is nothing but equal to delta y, isn't it? If you go from O to B, right, for O to B, delta y is equal to h, right? So now we want to find displacement. Think which equation of kinematics could we use, or which formula of delta y that we have derived earlier could we use? Which formula of delta y could we use, or which equation of kinematics could we use? Both ways you could do it. બધું same જ છે, બધું same જ છે, ગમે તેમ થઈ જાય. So suppose we do it by the formula that we have already written earlier. Okay, suppose we do it by the formula that we have already written earlier, that delta y is v0 sine theta 0 t minus 1 by 2 gt square, right? Okay, this is actually a longer method, પણ કરી નાખીએ, બરાબર ને? Now what is t for O to B? How much is the time? That is nothing but tm. હમણાં જ derive કર્યું. I hope that makes sense to all of you. So what we are going to do is we're going to put the value. We are going to put the value of t equal to tm here, right? So t is equal to tm, therefore h is equal to v0 sine theta 0 into t. What is meaning of t? Tm, but tm is v0 sine theta 0 by g. Any questions, anyone? T is tm and tm is this. Okay, I don't think anyone has any problem with that. Minus half g. Instead of t, we are going to write tm and it's square. So v0 square sine square theta 0 by g square. Okay. Can you do the maths yourselves, people? Can you do the maths? I'm giving you 1 minute. Come on, hurry up. I'm giving you 1 minute. Do the maths yourselves. Is everyone there? Okay. All right, Chintan. Yes, Priyansh. Yes, Divya, that's okay, that's right. Yeah. Yes. No, no, Falak, you made a mistake. See what you're writing. Half, ખાલી half જ આવ્યું દીક્ષિતા, બીજું કઈ નો આવ્યું? Zero no આવે, Ria. It's not possible. Check your calculation. Maximum height 0 કેવી રીતે આવે? Now you are guessing. Okay, now you are guessing, Ria. Do it again. Yes, Kavya, that's right. Preet, આને simplify નહીં કરવાનું. It is so ugly. Why don't you simplify it? Is it right? No, you have to simplify it, Gracie. આટલું મોટું તો હું ચેક નહીં કરું. Please simplify it. Yeah, now it's right, Falak. Yes, Joy, it is correct. Yes, Harsh. Raj, I don't know what you're writing. Something weird. બાકીની પબ્લિક ક્યાં છે? સુઈ ગઈ? Dhruvi, simplify it, please. Yes, Chintan, you can say that. Ami, only half answer? Half cannot be the answer, right? You'll get something else. Yes, Jaikit, now it looks correct. Krisha, please simplify it. Ayushi, no. Ayushi Mehta, not correct answer. Check your calculations. Sejal. Okay, Sejal looks fine. No, Ria, it is not right. You're making maths mistakes. No, Ankita. Yeah, Dharmi, now it's right. Yes, Raj looks okay, looks correct now. Gracie, it can be simplified. Dia Munjpara, yes, you have no half G cannot be the answer. You're cancelling a lot of things. It's not going to happen. No, Preet. Wrong answer. ચલો વાંધો નહીં, હવે હું કરી નાખું છું, હું કરી નાખું છું. Okay, my patience is running out. So first of all, you have to multiply this with this. So v0 into v0, v0 square, sine theta into sine theta, sine square theta by g minus. Now when we come to the second term, you're clearly seeing that 1g is going to get cancelled here. એક તો પહેલાથી 2g હતું અને એમાંથી ખાલી 1g થઈ ગયું. Okay, just joking, of course. G square હતું. Okay, so this is what you get. Now you see, you have to take LCM. You have to take LCM, or you could take common. Then તમને ફાવતું હોય એમ. V0 square sine square theta common upon G also common. Okay, so here everything is gone, so 1 minus here all this is gone, right? I hope you realize what I'm circling is common, right? So only that 2 remains. Okay, so 1 minus 1 by 2 is a grand 1 by 2. So this is your final answer. આવી રીતે લખાય નહીં, આ 2 ને આગળ લખાય. That's it. Okay, right? So this is what you get. Clear? So v0 square sine square theta 0 by 2g. Okay. Now see, this is fairly complicated in my opinion. આના કરતા ઘણું easy થાય બીજી method થી. Have a look at this. For O to B, if we use the third equation of kinematics. આ તો આવડે ને બધાને? For y-axis, okay? We are only interested in delta y, not in delta x. So we have used the third equation for y. Clear? Third equation for y-axis. Let's put all the values that we know. 2 ay is minus g. હવે તો ગોખાઈ ગયું હશે. Delta y is h. Vy, final y component of velocity. Which point is final? Which point is final? Look at this. Which point is final, everyone? કે એક મેથડ થઈ ગઈ એટલે ઊંઘી ગયા. Which point is final? B, yes, B is final, right? This is final. So at final, at B, what is the value of Vy? આપણે અહીંયા મસ્ત લખ્યું છે. Okay. અને આ તો યાદ જ છે, v0 sin theta 0, so its square is v0 sin square theta 0. બે બાજુ 0 minus this is minus this, right? 0 લખવાની કઈ જરૂર નથી અહીંયા. So now you remove the minus sign and tada, h is equal to v0 square sin square theta 0 by 2g. જો નવી મેથડ કરાવી તો 3 જણ ગાયબ થઈ ગયા. ઓકે, બરાબર ને? See, you can also write this as, you can also write this as, clear? I think you understand this as well, because v0 sin theta 0 જે છે, રાઈટ, એને આખું આમ લખી દો. આમાં મજા ન આવી, આમાં જ મજા આવી. 3 સ્ટેપમાં તો પૂરું કરી નાખ્યું, ઘર ભેગું કરી દીધું 3 સ્ટેપમાં. See, this is the power of thinking. આમાં થોડુંક વધારે વિચારવું પડ્યું. ઇફ યુ થિંક અબાઉટ ઇટ, આ એક એક્સ્ટ્રા કન્સેપ્ટ યુઝ કરવો પડ્યો. ઓલું ફોર્મ્યુલા ગોખીને બેઠા હોય ને એને જલ્દી નો યાદ આવે એવું છે, બરાબર ને? પણ તમે બધું સમજીને કરો છો ને એટલે તમને તરત સમજાય જાય. આ કેટલું લાંબુ થયું. ધીસ ઇઝ અનનેસેસરી ક્લટર. ધીસ ઇઝ સો એલિગન્ટ. ફર્સ્ટ એટલું હાર્ડ નથી, સાચી વાત છે સાહેબ, but it's long, right? I'm sure you'll agree with me, it is long. Second is very short. Okay, all right, so that's it, right? This is for maximum height. Okay, હજી કંઈક મને યાદ આવતું. All right then, so now if we, let me ask you one question, one very basic question. Okay, so for that we'll have to go back to algodo, right? There I'll write the question. Okay, there I will write the question. Okay, can you see the screen? I'm a screen sharing on there. Okay, so sorry. Yeah, now you can see algodo, right? Okay, right. So I was saying that if right now I'm throwing this, like let's see, right now we are throwing this at a speed of 10 meter per second, so that's the initial speed. The angle is 30 degrees. Okay, so let's do one thing, right? Let's take another case where we are throwing multiple objects. Okay, right? So what I'm asking you is, if you want to throw, if you throw it at 3 different angles like this with the same speed, I repeat, here I actually have 3 different objects, right? We are throwing these objects at 3 different angles. So this is at 30 degree, speed is 20 meter per second. Okay, now if I will send this to the back, okay, how to do that? Send to back. Give me 1 minute. Okay, so here is the red one. Okay, here is the red one, which we are going to throw at again the same speed, 20 meter per second. Speed badani same hai, right? All the 3 have same speed, but this one has angle 45. So let's just write that here as well. Okay, so the first one, it had angle 30 degree. The second one, it has angle 45 degree. Now there's a third one also, right? There's a third one also, which is hiding behind this. Okay, આ બધું બહુ ટાઈમે મેં યુઝ કર્યું એટલે હું ભૂલી ગયો છું કે કેવી રીતે બધા એના શોર્ટકટ હતા ને એવું. So here's the third one. So this is at what speed? Again 20 meter per second. I hope all of you are seeing it here. But this angle is 60. એટલે આમ એકદમ ઊંચું ફેંક્યું, બરાબર ને? આપણે પથ્થરો ફેંકો હોય કે બોલ ફેંકો હોય તો એ રીતે ઊંચો ફેંકી શકીએ ને, right? So that's what you are seeing, right? The three different balls being thrown at same speed, right? At same speed. How much speed? Same speed. Initial speed is same, 20 meter per second. See, initial velocity is not same, initial speed is same. Initial velocity is not same, right? Okay, so let's see what's going to happen. All right, so you tell me your prediction. You tell me your prediction, right? Which one will go farthest? Which one will go farthest and which one will go highest? બે અલગ આન્સર હશે, હોઈ શકે, I don't know. Which પેલા મને farthest નું કહી દો. Which one will go farthest? Which will go most far? Okay, all right, so I've taken your answers for farthest. And which one will go highest? Which one will go highest? Okay, someone said all will go at same distance. And which one will go highest? Okay, so general consensus, mostly people have said farthest the first one and highest the third one, right? Generally this is what you have said. It's not that everyone has said this, but mostly people have said this. Okay, most people have voted for this. So let's see what happens. Okay, all right, 1 2 3 vale ryu. So this is number one, right? White is number one, red is number two, and blue is number three. I hope you all can still see it, right? Okay, now would you like to change your opinions? Would you like to change your opinions? No? Fine, let's play it till the end. Let's see what happens. Let's see what happens. Let's play it till the end. Okay. See, now clearly this one is going to fall ahead of first, right? The first one fell here, right? I hope everyone can see that. This is where the first one fell, right? એટલું જ જોવાનું, આગળ નહીં જોવાનું, right? Clearly the second one that is here, it fell over here, right? Okay, right? And now the third one, what do you think? What's going to happen with the third one? What do you think? What is going to happen with the third? What will happen with the third? Okay, yeah, let's check. So Vedant, what you have read here is what you have seen, right? Okay, but now it's time to know why. See, this is what I've always been telling all of you. Physics માં છે ને કદમ કદમ पे ખતરા હોતા है, right? This is what you are seeing. તમે ગમે તેવું ગેસ કરો ને એ કંઈક બીજું જ નીકળે. Nature is full of surprises, right? So you see what happened to the third one is it went very high. The third one, the blue one went very high, right? And because of that, it got a lot of time. It took so much time to fall down, right? એટલે જ તે હમણાં આઈપીએલ કે એવું જોતા હોય તો તમને ખબર હશે, બહુ આમ ઊંચું ઊંચું મારવા જાય ને તો કેચ આઉટ થઈ જાય. હા, એક્ઝેક્ટ એક જ જગ્યાએ આવશે, બે એક જ જગ્યાએ છે. 1 and 3 are at the same place. Have a look. જો I hope that is clear. 1 and 3 are at the same place, right? 2 is farthest, right? Okay, now this actually happened because the angles were complementary, right? First no angle કેટલો હતો હમણાં પૂરું કરી છે એક જ મિનિટ last point that I'm going to make. The first one had angle 30 degree and the third one had angle 60 degree, right? These are called complementary angles, correct? Right, these are called complementary angles. This is what happens. So this is what Galileo proved for the first time way back. આપણે એવું અત્યારે એ જોયું જે Galileo prove કર્યું હતું પહેલી વાર, right? And the maximum distance, the maximum range જ કહેવાય ને આની રેન્જ કેટલી બધી સૌથી વધારે હતી ને, this one. I hope you see what I'm saying, right? This range was largest, આની range ઓછી હતી, right? The maximum range was for second one, which was at 45 degree. The maximum range was for second one, which was at 45 degree. So all this was proven by Galileo. We're going to prove it again, right, by using some calculations that would be done next time. Okay, these two ranges were equal. If you realize, R1 was equal to R3, right? Range of first was equal to range of third because the angles are complementary, right? Their total is 90, right? That's what has happened. Okay, so that's it. Then let's end this class today. I'm going to send you lots of important points and some homework also, right? Okay, yes, Street Genius is actually very nice. No, all ball did not fall at the same time, Ria, right? If you want, you can see the animation once again. All ball did not fall at the same time. Have a look. First the white one will fall, then the red one, and then the blue. All right, I hope that clears the doubt that you asked, right? Okay, પણ આ બધું તમને એટલે દેખાડું છું કારણ કે તમે ઇમેજિન કરી શકો પછી, બરાબર ને? એક્ઝામમાં એવું ન કહેતા સર આલગોડું આપો ચેક કરવું છે, એવું ન ચાલે. This you have to think on your own, right? You have to imagine, draw કરવાનું બધું. Okay, goodbye everyone.